That triangle up here, everything is marked. Every side is marked, every angle is marked. And I want to figure out, based on what's marked down here, which one do I know is definitely congruent? So what do you think? A, B, C, D.
I said A.
I heard an A, I heard a
D.
D. What else are we thinking?
A.
A? Let's take a look. If you remember when we did these before, we mark angles and sides. So I have an angle, side, side. Could I use angle, side, side for proving triangles congruent? No. Because remember when I was doing these before, I kept talking about you can't use ass and ass backwards?
Yep.
Doesn't work. So A does not work. B is only angles. Can I use only angles to prove triangles congruent? No. If you know all the angles, you can prove them similar but not congruent. So that one does not work. C, there's not even enough stuff because you have to have three things. So C doesn't work, which leaves me with side angle side. So side angle side is one of the ways we can prove triangles congruent. So if you remember, side, side, side works, side angle side works, angle side angle works, angle angle side works, and then if it was a right triangle, there was that special case which was hypotenuse leg works. So these are the ones that work. Angle 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 doesn't work. Angle side side doesn't work. Side side angle doesn't work. Those are the ones that do not work. So triangle congruence, based on what's marked, what's congruent? We okay on that? Next one. So we have this circle. And Henry is saying the more little triangles that we split the circle into, the closer the estimated area will actually be. So, like I said, two of them say yes, he's right. Two of them say he's wrong. So first let's decide, is he right or wrong? Bless you. The more triangles I split this up to, is it going to get closer to the area or not? Is he accurate or not accurate? Let's try something. So right now, he's got this split into 1, 2, 3, 4, 5, 6, 12 little triangles. So he got it split into a whole lot of triangles. But let's say he didn't split it into 12, he only split it into 4. That's what it would look like. Now, which is probably closer to the entire area? People need to pay attention. Too many people are staring at their phones. Is what he did with 12 little triangles closer to matching the circle, or what I did with 4 triangles? What he did. So the more triangles you have, the closer it's going to be to the actual area. The closer it will be. So, let me kind of scroll down here real quick. Make this a little smaller, but not that small. So we know it's going to be one of those two. Because he was accurate. Now, each of these little guys, that's a picture. So it's saying from here to here, it's the height of the triangle. This is the base. And basically you can take half the height times the base to figure out the area. So we're saying he's true, so it's one of these two. H goes closer to the value of R, or H gets closer to the value of 2R. That's the two big differences on that. So it's the H, which is from here to here, Getting closer to the value of r or getting closer to the value of 2r?
R.
R. Because it's really close to a radius, but it gets a little bit chopped off. But the more triangles we make, the closer it's going to get. So it's A. 2r would be the diameter,
Oh, interesting.
and we're not going all the way across this circle. We're only going from the center to a side. So that's this one. Next one. I've got these two triangles. It says they have the same angles, so I know these two triangles are similar. Well, once I figure out how big these are, I can figure out the perimeter. So does anybody have any suggestions on how I can find the missing sides of the little triangle? What can I do? I know the triangles are similar. I didn't talk about this yesterday.
You can divide by 2. Wait, that's dilating.
Yes, but if this would be 10, yes, 20 divided by 2 would be 10.
Yeah.
But it's not 10, it's 8.
Yeah.
But you're kind of on the right track. But it's not just a straight 2. So what can I do to find the missing sides of the little triangle? I can always set up what? What type of a problem?
A squared plus B squared plus C squared.
Yeah, it's not a right triangle. But good guess, though. Not a right triangle. I mentioned this yesterday, that similar triangles are always blank. Begins with a P. Proportional. So, if I know one side matches, the 20 is 8. So 20 over 8 is going to equal 14 over whatever this is. 14 over, I'm going to put an X. You can set up a proportion to solve for missing parts of similar things. So 20x, because you multiply diagonal, equals 14 times 8, 112. Divide by 20 equals 5.6. So I know this little guy is 5.6. That's that one. Now we're going to do it again. 20 over 8 equals 18 over, I'm going to use y just so it's a different letter. Multiply your diagonals. 20y equals 8 times 18, 144. Divide by 20, we get 7.2. So this is 7.2. So now I know the three sides of the triangle. So to find the perimeter of the triangle, what do I do with those three sides?
You add them all up.
Add them all up. So 7.2 plus 5.6 plus 8 equals 20.8. So basically it's a dilation, but they purposely didn't make it a straight, like half as big, fourth as big. They made it a strange fraction. That way you can just kind of look at it and guess it. You had to kind of know what you were doing. So anytime you're trying to find a missing part to a similar figure, proportions, proportions, proportions. Set up those proportions. Question there. Okay, so I've got this figure up here. We had these back a long time ago. But most people have been doing pretty good on this, actually. I know my two lines are parallel. They told us that. I'm missing some things, And in the end, I'm saying that angle 1 can be congruent to angle 7 because of something. And I'm trying to figure out the missing things using information down here. So, does anybody have a thought on how we can start this thing? Do you have any suggestions?
I said alternate exterior, but wouldn't that be number 3?
Alternate exterior is like the 1 and 7, but they're wanting us to fill in some more things, so they're not actually wanting us using alternate exterior. Because if we used alternate exterior, I wouldn't have even needed the 2 things in the middle. I could just go directly to alternate exterior. So, yes, but they wanted more stuff. Alternate exterior would have gotten us directly to step 4, and I wouldn't need anything in the middle.
Oh.
But they had something to do with angle 1 and angle 7. Because that's where it was in the end. So if I'm trying to get angle 1 congruent to angle 7, means I'm probably going to have to say something about angle 1. So up there's 3 different things about angle 1. Which one can I use?
One is congruent to 3.
So 1 is congruent to 3. I can say that. 1 and 3 is here and here. What type of angles are those? Vertical. So that's vertical. Now, that one works. You could have also, instead of saying 1 congruent to 3, 1 congruent to 4 doesn't even work because they're next door to each other. So this one doesn't even work. But 1 congruent to 5 also works. So that's my second choice. And like I said, there's kind of 2 different pathways I could take. So if I would have said 1 and 5, what's the relationship between angle 1 and angle 5? Not supplementary.
Transitive.
Not transitive. Remember, they're kind of in the same position, kind of on the left. So if they're in the same position, they are what type of angles? I kept saying same corner. If they're in the same corner, they are what type of angles? They are corresponding. Because I kept saying that, same corner corresponding, same corner corresponding. So corresponding. Now, let's go back to our first choice. We said angle 1 is congruent to angle 3. So now I've met up angle 3 to something, but I got to get to 7. And so far I haven't talked about 7 yet. So how can I then kind of get some kind of a chain reaction almost? Angle 1 is congruent to angle 3, and then I can say angle what is congruent to angle what?
Angle 3 is congruent to angle 7.
Right. So angle 3 is congruent to angle 7. Well, 3 is here, 7 is here. That's corresponding, same corner. So if I'm going this route, it's corresponding. Let's go ahead and finish this one. I'll go back over there. So 1 matches 3. 3 matches 7. So the first one links up to the last one. So if the first one links up to the last one, which one was that?
Alternate exterior.
Alternate exterior. Remember, alternate exterior, yes, is this, but they didn't want us to use that because then I didn't even need anything in the middle. But if I had that chain reaction, I had things linking together, and I kept talking about kind of a train linking together. Transitive. Transitive. Transitive is when you have different statements that link together. So 1 goes with 3, 3 goes with 7. So the first one linked up to the last one. Now, my other choice is 1, 5, but then I could have done 5, 7. 5, 7 would have been here, that's vertical. And then my transitive wouldn't have changed. It would have been transitive no matter what. Now, like I said, these proofs. Most of the proofs are 2 points. So on this one, there was 5 different missing spots. If you had 3 of them right, you had to have 3 of them. If you had 3 things in the correct positions, then you got 1 point. If you had all 5 in the correct positions, then you could get 2 points. And on both of these, if these 2 lines were completely reversed, that's okay. If you put this whole thing first and this whole thing second, that wouldn't have been a problem. It's kind of a strange link up, but it still works. So that's that one. That's that one. And that was the last one, wasn't it? Yes. Now, tomorrow, you're going to be getting the 2018 packet. Kind of the same ordeal, going through it, looking through it. I'm figuring Monday, we're not only going to go through some packet questions, we're also going to look at the practice test site, just so you can see what the calculator looks like, how you can get to different things, so that way you know where to find things. So the packet, if it's done, ready to turn in, I will take it. I'm going to give it back to you tomorrow, so that way if you want to look through things, you can.